and its surface area of a right prism. And when you do 148, when you do the surface area, you do the area of the ends of the prism, and then it's the perimeter times the height. And they're showing you on 148 formula for a right prism, then a right regular pyramid. It's the area of the base, and then that height of each of those triangles, 1/2 the perimeter times that height. And then the right circular cylinder at the bottom of the page is area of the top and bottom, and the circumference times the height. A right circular cone on 150, it's the area of that base, and then 1/2 of the circumference times L, which is the distance up the side of the cone. Sphere, it's 4 pi r squared. So we'll look at some example problems. Page 153. The right prism, there A. So they're telling us that each one of these sides is 5, this is 6. The quiz on Wednesday, just go down to Phil's office and pick it up and do it, because I'm going to be gone.
No class on Wednesday.
Just the quiz.
Understood. And then you submit it to Phil?
Yeah. Phil will have it. Give it to him. So what this is going to be, it's going to be the surface area is 2 times the area of each end plus the perimeter times the height. And that they've given all this to us. This distance right here is 4. So it's 2 times 1/2 of the base times the height, so that's 6 times 4 plus the perimeter is going to be 6 plus 5 plus 5 of that triangle times the height. So this is going to be 6 times 4, 24, plus 16 times 12. 192. I don't know if I added right. Is that right? 216? And that's feet squared. That should be the surface area. Then the B part, what we have minus 5. All of this is in centimeters. 4, 7, and 3. So the ends are the front and back, and those are trapezoids, right? And this, and this is 5 right back here. This thing right here is also 5. So the area of the the surface area is going to be 2, and the area of trapezoid is 1/2 of base 1 plus base 2. Well, base 1 is 7, base 2 is 5, times the height is 4, and then it's plus, and then it's the perimeter, and this is right angle. So what we're going to have to do to figure that perimeter, we're going to have to, this is going to be a 90, that's a right triangle, and this distance is 5. The total distance is from here to here, it's 5. And that makes it from here to here is 2. Because this whole distance is 7. So then we can calculate this is going to be that, and I guess I'll just call this A. A is going to equal the square root of, it's the sum of the squares of the 2 legs. So it's 2 squared plus 4 squared. 4 plus 16, 20. And that's going to be, 4 is going to come out, so it'll be 4 square root of 5. So what I have to do is I got to get this perimeter. This is going to be, the perimeter is going to be 4 plus 5 plus 7 plus 4 square root of 5 times the height is 3. So this first is going to be 13 times 4 plus 9 is 16 plus 4 square root of 5 times 3. So that's going to be 52. And at that point, I guess we could distribute the 3, so it's going to be 52 plus 18, 48 plus 4 times 3 times the square root of 5. That's 100. 12 square root of 5. So we could put that in our calculator and figure it out. I think the book actually figures it out. Clear plus, that was 4 square root of 5, wasn't it? What's that?
I feel like it should be 2 square root of 5.
Okay, we'll look.
When I'm just checking, 4 square root of 5 is 8
So where would this be? That's 16 and it's 3, right? You have to distribute the 3 that's got to be 12 there. That's got to be 16 and 3 times that's 48. I don't know. What number is this for? What did I get? What did I get for a number? 108. This is B. This is 108 should be right. 109 is what they're saying it is. Six. Did I here's what here I made a mistake here. That's 2 square root of 5. Because 20 is 4 times 5. That number right there is going to be a 2. This is going to be 2. So that would make this. This has got to be a 2. That's going to be a 2. This is going to be 6. Now, change this to enter 104. Rather than 108 is 104. Is that anybody? It's right in there. Somewhere. 472. It's right there.
The square root of 5 is around 2 and change, right? So 6 times that.
What's that?
Isn't the square root of 5 around 2 and change?
Yeah, something.
6 times that. Something's not right.
Did I put it in the calculator wrong?
Maybe. You got 2 up there, not 6.
But let's see. Okay. So enter. What was it? 6. Enter. 113. Okay. That should be right, right? What was it? 113 what? Something. Four, 1, 6. All right. 2, 4. It says find the surface area of each right prism with the given features, round to the nearest whole number. The base is a right triangle with legs of length 5 centimeters and 12 centimeters, and the height of the prism is 20. So I'm going to draw this like laid out. Hmm. And this is a right angle. And so the right triangle is the base. It says the legs are 5 centimeters and 12. So it isn't quite in perspective. But this would be 5 and this would be 12. And then the height, that's going to be, this is 20 along there. So we're going to have to calculate, to get the perimeter, we're going to have to calculate that C, which is squared 25 plus 144. 169, isn't it? And that's a square root of 13, or 13. So that distance right there is 13. So now what we do is the surface area is going to be 2 times the area of the base, which is 1/2 5 times 12, plus the perimeter is going to be 5 plus 12 plus 13 times the height is 20. So this is 60. 20. This is 30 times 20. Is that 600? 660? Did I calculate that right? 660 centimeters squared. All right? This was A. So the B part says the bases of an isosceles trapezoid with bases 4 inches and 12 inches, and with a non-parallel side lengths 4 and 4 square root of 2, which is the height of the prism, is 16. So I'm going to kind of lay that on the side because it's easier to draw. So it's an isosceles trapezoid. Oh, let's see. These two sides, those are supposed to be the same.
4 and 12.
this is 4, this is 12, and then these are 4 square root of 2, and then this is 16. That's an isosceles trapezoid. Then we got to figure out this height. Well, what we're going to have to do is these two little pieces here are going to be, this is going to be the distance from, the distance from here to here is 4. And the distance from there to there is 12. So that means that the distance here, that what remains is 8, and it's divided into the 2 parts. So each one of these are 4. Now what we can do is we can find that green, the height, is going to be the square root of 4 squared plus 4 square root of 2 squared. Square root of 16 plus 16 times 2. 16 plus 32. 48. And what is that? 4 times 16. So that's 2 times 4. That's 8, right? What is that? This factors into 4 times 12, which is 8 times 6. 4 times,
You can do 3 times
which is
16
4
as well.
times, which is 4 times 4 times 3. So it's going to come out with a 4 and under with the square root of 3. That's what that height is. So it's going to be 2 times the area of those trapezoids, and then the perimeter times 16. So the surface area, 2, area of trapezoid is 1/2, base 1 plus base 2, so it's 12 plus 4 times the height, and that height is 4 square root of 3 plus the perimeter. Perimeter is 4 plus 12 plus 2 times 4 square root of 2. And then that's times the height, 16. So that's 21 times 4 square root of 3. And that's going to be 18 plus 8 square root of 2 times 16. Square root of 3 I don't know if I can remember all that to put it in the calculator. Was it 8? 84 square root of 3. 84 second square root. plus, right? Bracket 18.8. Where would it go? Right. And what, that was, is that 16 wrong? Times bracket. Dang it, I put that bracket under that. So that's 2, delete, out from under there, bracket, times 16. 614.5. Is that what you come up with? Does that look right? I do something wrong. I did something wrong. This right here is wrong. Because that would be treatment of the hypotenuse. This is one of the legs. H equals the square root of hypotenuse, 4 square root of 2 quantity squared, minus 4 squared, right? So this right here is wrong. It's this value over here. Okay. It's this. Sixteen times 2 minus 16, which is the square root of 16, which is 4. So it makes this thing. It makes, I think this is right, isn't it? The parameter is 4 plus 12 plus 2 times 4 square root of 2. That part's right. It's this part right here. This is this would be. This is just 84. Now let's see if this comes out better. Go up here. And go in. I take out that square root. Huh. And delete. Now try that. I still do something wrong?
The first biggest will be 84.
This 1/2, that's 16 times 4.
64.
So this is wrong. 16 times 4. Lord. So that's 64. Boy.
Professor, what about the next portion of the equation? 4 plus 12 plus 2
Seems like it's
times.
See, it's 4 plus 12 plus 2 times this 4 square root of 2. Each one of these is 4 square root of 2. Right? So the perimeter should be this 4 and this 12, which is this whole length here. And then 2 times this 4 square root of 2. That should be right.
No, because you have 18 out front. It should be 16 plus 8 square root of 2.
Oh, I added that thing there, didn't I? Thank you.
Yep.
That's 60. Whew. Man. Now. So the first one was this first one should be 60. This should be 6. And that should be 16. Is that right?
Yes.
There. That's the number. That's the right number. $501 something. Jeez. Okay, let's see if we can do one without making a mistake. The top of a rectangular box has an area of 64 centimeters squared. Its side has an area of 42 centimeters squared, and its end has an area of 54 centimeters squared. What are the dimensions of the box? So this is 6. It's a rectangular box. Didn't want to do that. Okay. So this area here, 63 centimeters. Side is 42. And its end are 54. Not quite too good perspective. And so they want to know actually, the way the areas are, this would be length. No. This would be length, because that area 54 is bigger than 42. This would be width, and this would be height. I mean, 54 centimeters and 42, those two should be switched.
Right.
I guess I could make it,
You can draw it differently.
I could list it a different way. I could list it this way. Make this up. Make this one 54, right? Isn't that 54? And this one 42. Then this would be width, this would be length, this would be height. Okay. The dimensions, though they want those dimensions. So what do you think? So width times length should equal 63, right?
Mm-hmm.
And then length times height should equal 54. And then width times height should equal 42. So we got 3 equations, 3 unknowns. We should be able to solve it, right? We just pick one of them, write it in terms of the other, and then substitute. But it just makes no difference. We could take 2, 3. We could take 1 and 2 and get a length. We could go length equals 63 over width, and then you could do length equals 54 over height. And then you could go 63 times the width equals 54 times the height. And then solve for one or the other of those. Because this equation 3 has both width and height in it, so we could, I'll just take this and go h equals 54 width over 63. Then I'll take number 3 and substitute for h. So it's width times height, which is width times 54 w over 63 equals 42. And now you can get w squared is 42 times 63 over 54. Times 63 divided by 49. So w squared is 49, and w is 7, isn't it? And then I can get height here, 54 times 7 over 63. That's 54 over 9, isn't it? And that's 6, isn't it? So height is 6. So now I got W equals 7, height equals 6. And I just gotta go length. And take your pick. I can take that first equation, W times L is 63. L equals 63 over W, which is 63 over 7, which is 9. So there would be my 7, 6, and 9. All right, 8. This is find the surface area of each of the following right square pyramids. Round to the nearest whole number. Why does it keep jumping back? This is not too good. And it's showing this. This is a 90. This is a 90. And they're saying that height 17. This is 30. These are inches. That means that this side here is 30 because it's a right square here. So the surface area, this is 80. It's the area of the base plus it's the perimeter times the area of that triangle. Perimeter, the area of each one of those triangles. The area of the base is 30 squared plus the perimeter is going to be 4 times 30. And then each one of those triangles is 1/2 the base times the height. This is 920. And that's 15 times 17. Whatever that is. $900, $120. That's 9. 1275. Something isn't right. This is the area of the base, 30 square. And each one of these is 30, so it's 4 times 30 is 120. And it's this base times that height, and it's 1/2 of it.
You have to multiply it by 4 for each face.
4 times 30 is the perimeter. This is each area. Supposed to be bigger than that. Area of the base. It's 1,700, right? Each one of those triangles is 1/2 of 30 times 17.
Professor, perimeter times the area, not plus the area.
That right there.
Yeah.
So, there we go. Seems like that might be too much.
Is that it?
No, it's too much. I think it's got to be 4 times this 15 times 17, because it can't be the perimeter. I think it's the formula's here. I think this is where the mistake is. Enter, because it's 4 times the area.
Mm-hmm.
It's not the perimeter. I think this is it. That's it. It can't be the perimeter, because this wouldn't make sense. Because this is the area of each one of those triangles, and so it's 4 times the area. Actually, 4 times this area. So it's 4 times 15 times 17. And that was 1920, right? Yeah. I mean, the logic perimeter times that. You could go 4 times the perimeter, 1/2 of 4 times the perimeter times the height. You could do that, I think. You could go perimeter, area the base, 1/2 of the perimeter times the height. You could do it that way, I think. I'm not sure. Okay, so Wednesday, but this way of figuring it would be right.
So, Professor, the quiz is going to be just on 3.3, studying